Welcome to this episode of the Structural Engineering Channel podcast, a podcast focused on helping structural engineering professionals stay up to date on technical trends in the field and to help them succeed in their careers and lives. In this episode, we talk to Brian Trimble, a director of industry development at the International Masonry Institute. He will be talking about masonry, how to optimize structural masonry, the importance of teamwork, and why getting out in the field is so important to your engineering career.
I'm your co-host, Matt Picardal. I'm a licensed engineer at DCI Engineers, practicing on structural projects in California. I have an undergraduate degree from Cal Poly Pomona and a master's degree in structural engineering from UC San Diego.
And I'm your co-host, Alexis Clark. I work in Hilti's North American headquarters as the product manager of our chemical anchoring portfolio in the US and Canada. I'm a licensed professional engineer in Texas. I received my bachelor's in civil engineering from UT Austin, and I'm currently an MBA candidate at Auburn.
And now I'd like to introduce our guest for this episode, Brian Trimble. Brian Trimble has over 30 years experience in the masonry industry, assisting design professionals in the design of masonry structures. He's a frequent lecturer to local, regional, and national construction industry groups. He has authored many articles and papers on various masonry subjects. Brian started his career with a brick manufacturer and worked in the Brick Industry Association for over 20 years, serving in various positions. For the International Masonry Institute, he coordinates activities in the Western Pennsylvania and Western New York areas, promoting masonry to a wide variety of audiences, including owners, contractors, architects, engineers, and craft workers. Brian received his engineering education at Penn State University, where he received a Bachelor of Architectural Engineering degree in the structural design option in 1986. He was granted his professional engineer's license in the state of Virginia and is also registered in the state of Pennsylvania. Brian is actively involved in many organizations, including the Construction Specifications Institute, or CSI, American Society of Civil Engineers, or ASCE, the Masonry Society, TMS, and the International Brick Collectors Association, IBCA. Brian is also a fellow of ASTM International. Now let's jump into our conversation with Brian.
Brian, thank you so much for joining us today on the Structural Engineering Channel podcast.
Really glad to be here.
Glad to have you. Before we get kicked off into our nitty-gritty and all the exciting questions we have for you today, can you tell our listeners a little bit about your career journey and ultimately what you do on a daily basis?
Sure. I guess I took a sort of an alternate career path than many structural engineers. I graduated from Penn State's architectural engineering program, and I saw many of my friends getting jobs in, some of the large structural engineering firms. My first opportunity came as design engineer, working for a brick manufacturer, doing some special shape drawings on CAD, developing some technical documentation, things like that. I learned very quickly though, that there weren't many masonry experts out there. A lot of people knew about steel and concrete and things like that, but when it came to masonry, there just wasn't much. So I decided, well, maybe that's a good niche for me to be in. And so really, over my 30-year career, I've pretty much stayed in the masonry industry and mostly worked for associations. Now, working for associations, that's allowed me to really, my day-to-day activities are varied all over the place. So, one day I'll be preparing presentations and giving those. Of course, nowadays it's webinars. But then other days I'll be preparing technical documents. I'll be writing papers for conferences. So every day seems to be varied, which again, I think that's what engages us in work every day. So I've never had a bad day at work. Everything's always been very enjoyable. The other thing I get to do is I get to work with contractors and craft workers now in my current position. And so now I get out in the field. And so, one of the things I want to talk about today is really being out in the field and really learning a lot from that experience. And again, I get to do troubleshooting and, investigations and things like that a lot of people, enjoy doing.
Awesome. Brian, you mentioned that, there's a lot of concrete and steel experts. For our listeners that may be those that don't have too much exposure to masonry, can you go just a quick explanation of what masonry is and
Sure.
maybe the differences between brick and masonry if they're not too familiar with that?
Sure. Yeah. So really, masonry is sort of an all-encompassing kind of term. So anything that's really set in mortar or uses a masonry material, that's considered masonry. So anything that's dealing with brick, block, stone, tile, terrazzo, some concrete finishing, restoration, all those things sort of go into that masonry umbrella. And also talking about mortar and grout and things like that. So again, that's another reason this is an interesting job, is because it is so varied and so broad.
Excellent. Thank you so much for giving us that little bit of a definition, Brian. I know it's really helpful, not only for some of our professionals who maybe don't have as much exposure to masonry materials, but also we have a pretty hefty number of students that listen to the podcast as well. So we want to make sure we're being very clear for them.
Great.
So I know that the proper understanding of masonry can result in better, and not only better, but more cost-effective buildings, which is what our owners are always looking for. Do you have any tips that you can share with our listeners for optimizing structural masonry?
Yeah, I think the biggest issue would really be over-design with masonry, and mostly because most engineers are not familiar with masonry design. We get a lot of information or a lot of instruction about concrete and steel design, but again, masonry is one of those subjects that may or may not get taught at the university. And then you get some experience out in the field, but maybe, not some of those core theoretical things. So, I think that engineers tend to do more redundant systems when they're dealing with masonry because they don't feel comfortable with that. So we see a lot of people putting in, steel lintels into a masonry wall, when in reality, a reinforced masonry lintel would have been perfectly fine for that. So not only is it efficient, it's economical. Other things that we need to keep reminding engineers about is staying up to date. And of course, continuing education is all about that. But, I'm not sure how many of the engineers out there know that really the F'(M), the specified compressed strength of masonry, is no longer 1500 PSI. It's been changed to 2000 PSI. Well, right there, you're getting a better benefit of using, masonry more economically and so on. So, trying to stay up to date with current publications, current codes, again, through webinars and seminars and things like that is vitally important.
So I have to ask a little bit of a personal question. So I work with adhesive anchors, and they go into both concrete and masonry is kind of the little brother to concrete. But something that I've had to, be really aware of, and I've been working with recently, is some of the code changes that are being made to masonry codes.
Yes.
And you mentioned that engineers, we're perceived to have this tendency to over-design or be redundant in our systems. And I'm curious, can you share a little bit about how masonry codes have changed over time? You mentioned F'(M) has changed, and kind of where we're headed in the next few years.
Yes, in reality, there was not a really good structural masonry code until like 1995. So at that time, it was the ACI 530, ASCE 5/TMS 402. And over time, that there was more research being put into the masonry industry. The codes, were following a lot of that research, and really became better over time. So yeah, right now we're on the TMS 402. The 2016 code is the current version that's out there. We're working on the 2022 version. The Masonry Society, TMS, has actually gone to a 6-year cycle instead of the typical 3-year cycle, because it's hard for engineers to keep up with all of the changes that are occurring. So we thought going to a 6-year cycle might alleviate some of that. It also has more time for us to develop code changes. I happen to actually be chairman of the veneer subcommittee, exciting topics. And, again, it really has taken us at least 4 or 5 years to get everything lined up so that the codes will be as good as they can.
That's really interesting. I actually was unaware that they had switched to a 6-year cycle. And I think for the perspective of, the amount of practitioners, as well as, those in academia and all these different people who are coming together to develop code, it is hard to get things done and accomplished in an effective and meaningful way that also has a thorough amount of research and vetting and making sure that it makes sense for the code within a 3-year cycle. So
right.
I've only been involved in ACI committees. Have you seen that there have been noticeable changes and benefits to switching to a 6-year cycle over a 3-year cycle?
Well, so we're not done with the 6-year cycle yet. So some of that remains to be seen. But
okay.
From the development standpoint, it has been great. Again, we've had a chance to really vet a lot of different issues. We're talking about non-metallic rebar. We're talking about, a lot of different things, limit design, a lot of things that, people maybe is not familiar with are now becoming into the code. Now, the only thing is, some people would like to have change right away. to incorporate some of those things, especially as a manufacturer. You want to have your products, taken care of right away. But sometimes, you really have to wait for the next cycle. But yeah, I think it's going to be generally viewed well. I know ACI and other groups have talked about going to a longer cycle. But again, a lot of those associations also rely, institutes rely on money from sales of publications, and a 6-year cycle is difficult.
Very cool. Thank you for those insights.
Yeah.
Yeah, Brian, I wanted to touch back on that point that you made that, definitely not a lot of students get masonry. For me, I didn't get any masonry classes. And when you get and jump into the industry, it is kind of just like, hey, go figure it out by yourself. It's like concrete. And then you're, as a younger engineer, you're kind of given resources. And if you don't have the right resources to go about it. But, what I found is, at least in my design studies and during in the workplace, we use masonry, but we tend to use it a lot with, it's not just masonry, it's used a lot with steel and wood. Could you go into a little bit more about that, how that is like in the industry when you're working with all these different types of materials?
Yeah, I mean, certainly when you talk about things like reinforcing steel within masonry and so on, they're very compatible. In fact, without reinforcing steel, masonry couldn't really go to where it is now with all the tall structures, especially in seismic areas and things like that. But I think it's really, designing with wood and steel and things like that, and along with masonry, you just have to know the different properties. And one of the biggest things that you have to deal with are issues with differential movement. So, for example, if you're doing a wood frame building with a brick veneer on it, you need to know that the wood frame is going to shrink over time, and the brick veneer actually is going to grow, and those are their natural material properties. So putting those two materials together, you have to detail or design things so that they all work together. And same thing with steel. I mean, steel expands at a much greater rate thermally than masonry does. And so just recognizing that, in the design, I think goes fairly well. So again, I encourage, designers to use all the different materials. Just, understand what they can and can't do.
I really like the fact that you said kind of putting it all together, because of course our buildings are rarely made of one material. It's a combination of various materials that we have to, not only work with all the different thermal coefficients, but just make sure the entire structure works as it's intended. When we talk about bringing it together, there's definitely a piece to academia that kind of lacks representation of what we're really dealing with on the job site, which is time in the field and actually seeing all of it come together and constructability. For those listeners who are specifically in engineering school who haven't had that experience yet, what advice can you provide to those listeners about the importance of being out in the field and not just keeping your eyes directed at the whatever's happening on your screen in the design office?
Yeah, I mean, obviously you have to have that knowledge of structural engineering. I mean, you have to have that, but I think it's also important to have that experience with what actually gets built in the field. I mean, as a young engineer or even as a student, going out there and looking at construction sites, and all of a sudden you see things like the steel connections and how they go together and how complicated they can be. You look at the rebar congestion that occurs in concrete, and it's like, how could they possibly pour concrete around that and get it, all as one monolithic assembly and things like that. So, and then, from masonry standpoint, you go out to a field, you see these masons, saw cutting these brick and block. And it's like, why are they doing that? Well, because the masonry wasn't, or the wall wasn't designed on an 8-inch module, which helps things even out. And again, some of that field cutting could easily be taken care of by understanding some of those things. So I think, as an engineering student, I think one of the best things you can do is to get some field experience. So maybe, not even going into a design firm and doing an internship there, maybe actually going out into the field and becoming a craft worker and interning as a laborer on a project, or working for a construction manager or general contractor, where again, you see that on a day-to-day basis of how things get put in place. And also hearing some of the concerns that are coming in. It's like, oh, wow, I didn't realize that was an issue, but every day they're talking about this. And so when you go into your own practice, you'll know about those things.
Absolutely. That time in the field and learning from the people who are doing the actual work, or even better yet, being alongside them, is integral to being a fantastic engineer, because at the end of the day, what you're putting on the plans has to be executed by someone. And if they either can't understand what's going on, or if it's just not feasible to do, they're going to be the ones who are going to tell you immediately. And you can save yourself a lot of heartache if you can get the experience up front.
Yeah, and one of the things that I was involved in a project recently. It was a perforated brick screen wall It was on a radius, and it also leaned inwards, as you rose up the height of the building. So a very complicated type structure. And so the architect, the engineer, they had developed everything in the BIM model, and they had the laid out course to course, brick to brick, and everything else. So, it seemed like, of course, that could be done easily. Well, they actually did a mock-up within one of our training centers, and we found out that, it's not quite as easy to put together the way they had planned it. I mean, again, it's taking people and actually, using to install these products. And so they found out that, string lines had to be used and different kind of jigs to help position the brick in the right place for that to occur. So without that, sort of communication, which again, you sound like a broken record, communication's key. And it is, because again, just having those designers and craft workers together, talking these elements over, I think is critical for the success of a project.
Yeah, and I know you stated that, craft workers, they may know things, how to put stuff together better than the design engineer. They may not know the theory, but in terms of constructability, I think that's why it's so important. And I know that's something that you believe also. Do you have any other examples or tips on maybe how you can bring those two together, maybe the craft worker and the engineer, how to improve their communication, or examples of when it went right, when it went wrong?
I think, again, it's really a matter of just keeping an open mind on things. So I think the engineer and the contractor and all the other team members sort of have to get together in a collaborative way, because again, that's where, we work together the best. We don't want to have that adversarial relationship. And I think the more times you're talking about things and trying to work things out, I think the better things are. We had a recent experience. My associate in Wisconsin, Pat, was on a project where the contractor was recommending that this large gymnasium wall not have any control joints in the concrete block. Now, control joints are usually put in concrete block to help deal with movement issues and things like that. Well, the contractor, had enough experience. It's like, there's a lot of openings in this wall. There's a lot of bond beams. There's a lot of horizontal reinforcement in this project. I think this is a perfect example where, control joints can be eliminated. Now, think about this. This is a 200-foot long wall that's about 60 foot high. And it's like, okay, control joints from my, experience are placed about every 25 feet in a concrete block wall. So how can you eliminate one in a 200-foot long wall? Well, again, the craft worker knew that having bond beams at these different locations would actually put a lot of steel in there to take any kind of the, tensile forces that are developed with dealing with the shrinkage. And again, because of where the windows were placed and so on. And they had reinforced masonry lintels across all the tops of the openings. And so again, there was a lot of horizontal steel. And going into, the literature from the National Concrete Masonry Association and CMA, they have a tech that deals with this subject. And along with a consulting engineer and with IMI, they were to come up with a solution that did not contain any control joints. And without that sort of collaboration, this wall would have been built and could have had cracking, or it could have been just very expensive. And now we have a more elegant and efficient solution.
Perfect. Thank you for that insight, Brian. My next question is kind of generic to all materials, but just a little bit about how we can be better as engineers and more thoughtful. How do you think we can use materials in construction to their fullest extent?
Yeah, of course, I'm dealing specifically with masonry, so I have a narrow focus on that. But, a lot of times people look at masonry just for aesthetics. And really, masonry is a lot more than that. Masonry is a very strong material that can be used in, many types of load-bearing applications. So, things like schools and other projects, again, don't design in a redundant steel structure if you don't need to, when the masonry itself can take the load. And of course, nowadays we're talking about resiliency. And again, and that is somewhat redundant to a certain extent, but, we want to have materials that can, do multiple purposes. So, not only be as load bearing, but also could be the enclosure that can also look good and so on. So I like to think of masonry as having a lot of those qualities, that masonry is inherently resilient. And I think, again, that helps push our, goals of having safe structures to live and work in.
Brian, I had some questions about more of a advice for if I'm a younger engineer and you had to work on a masonry project and you've never seen it, what would your advice to those younger engineers be? Is it maybe a resource that they could go to learn more about masonry? What's the best way for younger engineers to learn about it?
Yeah, so for masonry, again, there's a lot of information out there, available to designers. So you look at the Masonry Society, TMS, and they have a lot of publications. Not only do they publish the code, but they also have other manuals and things like that that can help designers. Also, all the different material associations. So the Brick Industry Association, the National Concrete Masonry Association, the International Masonry Institute, who I work for, we all have publications on our websites that really help the engineer go through some of these somewhat complicated procedures and make them easier. And of course, again, because they may not be as familiar with them, make them feel more comfortable with designing with masonry. So yeah, so I think there's a lot of publications that are out there. And again, myself included, along with the other IMI staff, and as well as the other associations with BI, NCMA, we have technical people on staff that are there to answer questions every day. And, we get thousands of questions in every year on different subjects, and we're never, no one should ever be embarrassed to ask those questions, because we have the answers. We just need somebody to ask them to help them out. So the information's out there.
Yeah, Lauren, I think that's something I wish I would have knew. For me, when I was learning it, it was going through the codes and the resources, and asking obviously the principals and whatnot, but going to the experts and calling up an actual expert, I think that would have saved me some time, because there's so much to masonry. Like you were saying, there's masonry, there's brick veneers, even glass block that that I've done too. It's a big world.
Right. So, don't be shy. Sometimes we're so engrossed with emails and computer stuff and so on that we fail just to make a phone call and so on. But emails are fine too. We'll be glad to answer those just as easily as everything else. And, we're willing to share. You just need to reach out.
So I love that you make this plug to kind of reach out and start to engage with your organization, because this kind of follows a similar thread to any of our listeners who would have heard our episode with Jennifer Tadaro 4 or 5 episodes ago. She works for AISC, and she's saying she shared with us a lot of those same sentiments. I mean, they have technical experts within these industries, within these institutions and organizations that are there to be those resources for you. One of the things I think I benefited most from when I was a student was being able to exercise different opportunities to go to, for example, an ASCE conference or a structures conference. And even if I didn't go to a ton of sessions that may have been a little bit over my head at the time, one of the things that I did enjoy was going to the expo of all the different vendors. And one of the linchpins in all of these expos is the organization is going to have a small library that's available there. And there's a ton of different publications that are available. When I was in college, I really wanted to work in like restoration and preservation of old historic masonry buildings. Not a ton of those in Texas, but it was what I wanted to do. So I went to one of those libraries at an ASCE conference, and I ended up buying like 3 or 4 booklets that weren't terribly expensive. They were $18 to $30 a pop. But I have, a nice little collection of different studies about how masonry works and these different old structures and studies that have been done. And I probably reference them once or twice a year, but that is a really great way to get familiar with not only an organization and go to their event and start to meet people and network, but also to learn about those materials that you maybe don't have as much exposure to in your coursework, and also get a feel for some studies that are out there that you may not have access to on Google. Half of them you look up and they're either protected by the university or it's confidential information or something else. So
right.
A lot of great resources there. So I'm glad you bring up those publications as well. It's not always about just the code manual.
Right. Yeah. So they're all out there. Again, I've written several papers on some very niche type things on perforated screen walls. And again, people have contacted me because they've seen that article or whatever and said, hey, what do you know about this? And so again, that just making those connections is great.
I love it. I also have to admit, when you first gave us a little bit of your description about what your day-to-day job looks like and what your career has been like, it sounds like a lot like my role in engineering marketing at Hilti is, I'm creating technical content and education. And I think that is so much fun. It's one of the best things. I have a total blast with it because you're dealing with all those technical concepts you love to work with all the time, but then you get to share the love, and you get a megaphone and someone lets you yell it on the rooftops about how cool your engineering stuff is. So I think it's very neat, the work that you do.
And I'd have to again plug the idea that people should get more involved in the masonry industry, because again, there's a lot of people that dealing with concrete and steel, and you're going to get lost between amongst all those folks. In masonry, you can really make a name for yourself, and again, it's a fun group.
I love that. That's a great plug. Maybe I'll come and join a committee. You've already convinced me.
I have some things they can work on.
Perfect. Wonderful. So to those listeners who just heard a calling of, you should get involved. Whether you've taken a masonry course or not, or if you've only dipped your toe into a couple of building designs with masonry, they're open doors and opportunities to be had if you're looking for a way to learn more or evolve your resume a little bit.
And Brian, my last question, did you have any advice for engineers that want to go into the construction industry? I know you're a big advocate of construction, but if an engineer wanted to get into the construction engineering, do you have any advice for them?
Well, yeah, I think for younger folks and that kind of stuff, I would say definitely, work with your professors, first of all, because they're going to have some of those connections, that you're looking for. I know, again, my background at Penn State and so on, Kevin Parfit was my professor, still there at Penn State. And he is one who connected me with a lot of people that I needed to know about when I was still a student. And so I think, working within your, that small network and expanding that network into something greater, I think is good. And as I mentioned before, I think it's really important to, work in the field, to have some of that experience to draw back on, because you can say, I was on that house construction and I saw how they put the studs together, and I'm now designing a 5-story building with wood frame construction. Now I know how it goes together. So I think, again, just getting involved more in construction, even as again, a structural engineer, civil engineer, whatever, I think all those things are important to really focus in on.
Yeah, that's great advice. I know just from my studies, my professors, they have to know the structural engineers too, but especially if they're doing testing or whatnot, then they have to know the construction workers and the contractors that do them too. So definitely it's a great resource, because your professors will probably know them if they're doing any kind of testing.
Yeah, and again, respect, goes all around. So respect the craft worker, and hopefully the craft worker will, respect the designer. And so, I think it goes around. Respect is important for that communication that is vital.
Absolutely. I think one of the most important things I learned from my most design intensive internship I had was in bridge design. And for the first 2 weeks, they just sent me out with the inspector that I had on staff, and they said, just ask him every question that comes to your mind, because watching a bridge being built is so different than designing it. And, watching them put in zip strips and asking all the questions and being out on the job site at 4 a.m. when they're trying to pour concrete in the Texas summer, that is a transformative experience. And it humbles you. I have lots of listeners. We have lots of young engineers who are excited and who are in the technical nitty gritty. And I know Matt and I get a lot of questions all the time about, what computer program should I know, or what design software should I be familiar with? And there is nothing that is more valuable than realizing that in your engineering career, when you get that degree, it doesn't say that you're a genius. It doesn't say that you are the all-knowing structural engineer. It says you know how to learn, and you're willing to learn and be eager to learn. And the first thing you have to do when you step into your job day one is be humble and ask the questions so that you do actually understand, and realize that the inspector or the construction, the craftsman who's been on the job site for 5 or 10 or 15 or 25 years, they have a lot of experience and they know a lot that you can learn from. So be open and excited to accept their wisdom and their advice.
Yeah, I wanted to touch on that point too. So, sorry, Brian.
Just one thing I want to say here is also you have to know when to call BS too. So if the contractor is trying to give you a line of something that's that's not right, you have to be able to know that that's not the way things are done. So you have to know that side of things as well.
Yeah, there's definitely a balance.
Yeah, for sure. Yep. And it's like, both ways. But I know, at least for me, sometimes it's I might save myself another RFI or another repeat if I just talk to the contractor and just like, hey, here's what I'm thinking. Right. What do you guys think? And then it'll save you time, because they might catch something that's, you're not out in the field. They are, and they might have some extra material that they can use right away. So definitely getting their input. That's what I try to do, when it saves me RFI sometimes, because as an engineer, sometimes you'll put a detail out, but then it'll come back because maybe it doesn't work with what they have in the field. So definitely that communication and respect for the craftsman definitely helps.
Right.
Brian, thank you so much for that fantastic insight that you've shared with us today. I think you really gave us a well-rounded amount of experience from not only your career and what it's like to contribute in one of these, I want to say like a base material society, but in an industry organization. And I think you've given us a lot to think about how we can be better engineers by understanding what's really going on in the job site and how we can be more effective with the materials that we have at our disposal. Thanks for joining us.
Thank you very much for the opportunity.
We hope you enjoyed today's episode. We'd love to hear your feedback, comments, and or questions. To leave them, please visit structuralengineeringchannel.com. There you'll find a summary of the key points discussed in today's episode, which is episode number 41. You'll also find links to any of the resources, websites, or books mentioned during this episode. And don't forget to subscribe on Apple Podcasts or wherever you listen to your podcast. Until next time, we wish you the best in all of your structural engineering